4-ball tribometer is used to measure wear and friction performance of a tested lubricant. The lubricant to be tested can be in either liquid form, for example oil, or semi-solid form, for example grease. The machine works by rotating one upper ball on 3 stationary lower balls that are submerged into the tested lubricant. So the data obtained from the test are coefficient of friction and wear scar diameter. The coefficient of friction is obtained from the graph plotted by the machine, and the wear scar diameter is obtained by measuring the scar on the stationary lower balls. So let's get to the experiment. So we're going to do this work according to American Standard ASTM D2266. American Standard lah for tribological test.
Okay.
So this is the timer. This is speed in RPM. This is temperature in Celsius. This is the friction torque that we will use this to convert it into coefficient of friction. Depends on the data that you need. In my case, I need coefficient of friction, and then this is going to be the load that we're going to put on the test balls lah. So for the American Standard, it's 1 hour. So we need to set it 1 hour. So second, minute, hour. So 1 hour. Okay. So for the RPM, it's 1200. To test the RPM, we just start. And then we adjust the knob lah. The temperature when there's we need to connect it to the this one. There's a wire that we need to connect the wire here, and then it will hit this holder to 75 degrees Celsius lah. And the friction torque, when we start, we need to put it at 0. Okay, so for the load that we're going to put is 392 Newton. The friction torque, this point, when it spin, it will go against here. So if you can see, when I touch here, the friction torque will increase. See, now I touch, it will increase. Now I release, it becomes 0.
Okay.
So this is where the friction torque is measured lah. So right now I just want to adjust the load. So this going to be, the load will be applied underneath. It will go here. So this is the level. When I hang a load, you can see this it will go up. So that's how the load is applied lah, and you can see that from there I applying load, so it's increasing, and now I'm released. Okay. because our measurement is at 0.0, so it's better to clean everything because we cannot see. And normally people will use this with oil, so I don't want my grease to be contaminated. Okay, so that's out of the way. So now, actually it's better we have glove on now.
Yeah, it's okay.
Okay, first we're going to fill this half with our grease. I need to clean my bowl. Slowly, no? Okay. So we run the paper cloth lah. So later if we need, just take lah.
Okay.
So clean lah. Okay, just now fill this with all this. So this is actually brand new, so I don't need to clean it with acetone. Super new. Okay, so just take a few, put down there, and spread. Okay, and give a smack. That the grease will
Settle down.
settle down. After this is filled, half filled, half or mostly filled, doesn't matter. As much as you can lah. Okay. Now we put our balls. Then we will use this guy. This will lock our ball, so when the test come, it will not move. And the excess grease, just push it back like that to feel, you saw the gap. Okay, give another smack. Okay, just like that. So okay, so clean wipe all the excess, and then just double confirm that this is how we call it, as tight as possible. Okay, so it's fit. Okay, now just lock. Okay, however, when you lock it, just how we call it, hand tightening. Okay, and then we need this to the cup. This is because based on the standard, we need to tighten it according to like this. Okay, so 50 So locking nut. Just now is the centering ring. Here, just to further tighten it. When you hear the okay, finish okay, so the top wrench here, and then you see there's like a rise, right? So just give a here, sorry, this insert here. Okay, see, that's the jig. That put your ball here, here, and then just push until you get the sound. So now, okay. Make it circular lah, easier. Okay, enough So just need to slot it here so it's in. Put it here. Put it here. Make sure the sleeve okay, in the center lah. And this also we need to check for center. Okay, now everything is good okay, so now we can insert this and hit our this is to hit it to hit this so that it will reach the preset temperature. So that is our load. Our top is at 0. Double check. Okay. This is the file that we're going to use to read the data, the experimental data. So we're going to use this software Wincom 2010. And okay, if we're going to start, we're going to put our file name and also all the description, what standard they are using, the load, RPM and temperature. This is where we do it lah. And then we need, in order for it to continuously read the data, we need to run it for continuously lah. But to read the data that we have produced, we go to the wear test, and the data that it's going to read is the coefficient of friction, but the average coefficient of friction. However, the graph that they are going to show is based on the experiment, which is frictional torque. Over here, it's already calculated and converted lah. Okay, so to read the data, you just click run continuously and click your file and then choose the file that you want to read lah. So one of my previous data is this one. After you put your data, just hit refresh, and over here, go here where it will read, not read, it will zoom in as a best fit for your data. So that's why we cannot see earlier, because my data is at 0.07 and the average coefficient is 0.03725. It's very near to the zero level lah, that's why we cannot read. Okay. So to compare, just open another file. You can choose number 4 and click refresh, and you can see that put here the best fit. Click here again, best fit. So you can see that this is for comparison purpose lah. So we continue lah. So we finish here. We go to acquire. Everyone just click, just leave it be lah, run continuously. So now our file name for today is I will just continue my previous work. So ASTMD 2266 continuously. Okay, so I click start. Start. This first lah. So remove this first because it's hot, and then remove the load. Okay, just take this out. Super hot, super hot, super hot.
Too hot?
No. Set it here and then just like that.
Okay.
Then there. To look at your data, this is for the best fit. So best fit. Okay. So this is for the peak and height. Here. Okay. So like that. Again,
Okay.
So best fit. This is for you to observe based on the peak and height. So let's say this is the highest point. So I just find the lowest peak. So this is the lowest peak, and so you see, this is lowest peak, this is the highest peak. So it's like that. Okay, it can be used to observe. Let's say like here, I want to see how much it dropped. So it dropped around 0.08 to almost 0.06 lah. Okay, and this is for zoom out, this is for zoom in. So let's say I want to see the data here, so I just zoom, see, it zoom in, and to zoom out, like that lah.